Welcome to screencast session on week 4, finding the connected components. For this, we are using the existing implementation of BFS. So as you know, the BFS will take the support of that existing queue implementation. This is the queue which is already available from the week 3, and this is already available BFS standard implementation. So which it returns that whatever the vertices has been widgeted, that is definitely it's a true or false. So let's go for the components now. So simply the component means it might be a disconnected group of vertices or vertex inside the same graph. The graph is same, but vertices are disconnected. So we want to count it how many component IDs are there. So each particular vertex belongs to which component ID. So that is what the objective of this implementation. Let's start the implementation. So we are having some kind of initiation part. So we are taking the component, so where it is that empty dictionary, and we are taking that two more integer variables, that is component ID, and we are taking one more is scene. So these two are initialized to 0 because they are just, it is a counting variables, which is the component ID we are counting, and how many of the vertices has been widgeted or seen. So now let's go for that, the particular setting of that each vertex components. Basically each vertex, it belongs to which component it is. So for that, for each vertex in that adjacency list of that keys, so in that we want to make it default component, it belongs to us -1, because we don't know that. So which component it belongs to is just, it is a -1. So that what happens, basically everyone knows that it does not belong to any kind of component. So now let's go for that the iteration of the while loop. So this while loop, it repeats that until all of our vertices has been widgeted. How would I know as the maximum adjacency list of keys? What is the maximum value is available inside of your graph? So that maximum vertex value we are getting. So this is the max function which will pick out that what is the maximum value of the vertex. So in this, so we want to find out that maximum. So we got the maximum in this. So we want to find out that starting vertex, what should be the starting vertex. So the start vertex I want to take as the minimum of unvisited vertices inside of your adjacency list. So let's do that for I. So inside of your adjacency list of keys, so in this, which of them are not widgeted only, that particular, so component, that particular I, which it is not belongs to any component. So that by default it contains -1. So that definitely first minimum value is selected, first minimum vertex is selected. Now let's call that existing function already available, BFS. So the BFS, what it will do, it will return that a widgeted dictionary, it contains the true or false. So that is BFS is started from the adjacency list. What is your starting vertex? So start vertex is already we got it, which could be the minimum. So in the line number 54 we got it. So the BFS function, I hope it is declared as BFS list. Yes. So we got that widgeted true or false one. So whatever widgeted we got it, so that we want to assign each component ID. So for that we want to do a iteration for v inside of your, so widgeted keys of it, whatever widgeted keys we got it, because widgeted is going to be true or false. So in this, if whatever the widgeted is there, whatever the vertex is widgeted, if that is widgeted, so then simply we want to increase the scene value +1. So that scene value +1 means keep on increasing how many vertices in the graph has been widgeted. So this will belongs to that this iteration stopping of the loop until my scene value reach to that maximum number of key value, maximum number of vertex value is reached. So that is done. So every time whenever we got it, which component it belongs to us, so the component we are updating that it belongs to is whatever current component ID. So as you know that component ID already we got it is that, so -1. So that component ID we want to get it. So in this, So we are updating for the component. After getting for this component, we want to increase this component ID, because once that a set of group of vertices has been visited, next minimum we are getting. So that maybe 1 2 3 are connected means one minimum you are getting. We try to traverse from that. After 3 of them are finished, maybe 5 6 7 is created as another component. So out of that 5 6 7, so fifth minimum one we are getting, and we are trying to traverse that. So BFS traversal from the fifth vertex. So for that, every time we want to increase the component ID is +1. So it has done everything. So basically finally we want to return so the component details, so that all the vertices belongs to which particular component they are. So that components we want to get it. So we got the component, so whatever the component details are there. So now we want to implement the main function. So the main function where I'm giving some of the components are connected, some of them are disconnected. So let's do that. So the adjacency list which I'm giving is 0 is having adjacent of 1, and 1 is having adjacent of 2, 1 is having adjacent of 2, and 2 is having adjacent of 0. So these three are definitely they are connected, 0 to 1, 1 to 2, and 2 to 0. Definitely these three are connected. So now 3 is connected exclusively for 4 and 6. So then 4 is connected exclusively for 3 and 7. 3 and 7. So now 5 is connected to 3 and 7. So 3 and 7. And then 6 I am taking, 6 it belongs to that, 5 only, it is having only the adjacent of 5, and 7 is having 4 and 8. So here it is 5, and then it is 3 and 7. Yeah, maybe syntactically something we have to fix it. So now 7 is connected to something, 4 and 8 we can connect. Now 8 we are connecting to 5 and 9. So maybe it's a last vertex. 9 we are connecting to only 8. So this is okay. Maybe somewhere I've been missing with yeah, it is okay. It's a comma separator I supposed to use. 3 and 7. 5 is having two adjacents. 3 and 7. Yeah, good. So now let's call that your function, which is components function. Print that components. What we are sending is the adjacency list we are sending as a parameter. So hope it is done. Let's run this. Yeah, if you could see that, so the 0th vertex, first vertex, and second vertex, these three belongs to the component ID number 0, because all these three are grouped. They are not connecting to 3, 4, and 5. So that's the reason these three are belongs to one component. And now 3, 4, 5, 6, 7, 8, 9, and 0, sorry, 8, 9, all these belongs to component ID number. It's a 1, because here this graph contains two components. So three particular vertices belongs to that component number 0, and another 6 vertices belongs to that component number 1. Maybe first component, second component also you can consider. So hope you understand. Thank you very much. Have a nice day.